CRISPR is a molecular scalpel that we can program to cut any DNA sequence of interest. CRISPR is one of the tools that is making biology become the new digital.
CRISPR allows you to essentially cut and paste different pieces of code. It's molecular scissors.
It really came on the scene only in 2012, but since then we've now used it to engineer dozens of species, including come up with a way of altering a single organism with CRISPR, and then potentially having that alteration spread through organisms in the wild. So malaria is so devastating, kills 400,000 kids a year, that I have yet to meet any scientist or ecologist that can come up with any possible set of unexpected side effects that they can dream up that would be worse than malaria, because malaria is just that terrible. Instead of spraying DDT everywhere, what if we could alter the handful of mosquito species that spread it so they can't do that anymore? Or, if necessary, to remove them. So when you're evaluating whether to do this, you have to say, okay, well, what could go wrong, how bad could it be versus how bad it is? And malaria is just so bad that it tips the scale regardless of what you put on the other side.
I think one of the most exciting possibilities is creating more sustainable production with biotechnology and dream up new things in partnership with nature.
Instead of speaking to nature with bulldozers and toxic chemicals, we can speak the language of DNA. That is the language of nature. It could revolutionize virtually every industry that involves making something that a living organism can make. Any material that's even remotely biological. CRISPR-based gene therapy has tremendous potential to address many different genetic disorders, particularly those of the blood. It could address many different diseases. It will definitely make a lot of sick people well.
People always love to ask about worst-case scenarios. The modification of our genetic code, modification at the embryo stage, I think that we need to be really sure about what we're doing before we engineer something that allows all humans to be more frail, or we engineer systems that allow us to be more susceptible to disease.
Worst case for CRISPR, it's the usual risk that someone's going to create a nasty pathogen that could end up affecting us all. That's always been the risk with bio, but some human could do it deliberately or by mistake. CRISPR just accelerates everything that we do in the laboratory with biology.
I think one of the biggest challenges is how we can worry in a productive way. It's important to think about all the things that might go wrong, but not to hide it away.
We're going to have to change how we do science, because right now we do it behind closed doors. And it's just not right that a technology that could affect everyone be developed behind closed doors. We have to change the way we do science, because this is just training wheels for the technologies that will follow.